So exercise electrode potential and the transition metals. We did first 16 questions, so we're doing question 17 now. Question 17, the +6 oxidation state, there are many compounds that contain element in a +6 oxidation. Similarities between sulfur 6 compounds and chromium 6 compound. For example, sulfur is forming sulfate and disulfates, while chromium is forming a chromate and dichromates. Other transition metals compound exists with the metal oxidation state +6, like potassium. Manganate 6 is there, can be prepared in alkaline, but it is readily disproportionate in neutral or acidic solution. And then potassium ferrate 6 is there, obtained by heating iron fillings with potassium nitrate, and then pouring the cool mixture into a water. Draw a dot and cross diagram for a sulfate ion. So sulfate ion, sulfur and 4 oxygen are there. So sulfur is forming a bond with, so how we can represent, sulfur belongs to group 6, so group 6 element share 2 electrons, that is, but sulfur, when you write the electronic configuration for a sulfur, which is 16, so it is 1s2, 2s2, 2p6, 3s2, 3p4, and 3d is also available. Like, it is empty, but it is available. It can adjust the electrons. So that's why sulfur, even though it need only 2 to be stable, but it can adjust more than that because there's an empty d orbital. So when we draw a dot and cross diagram, so if sulfur, like oxygen, and it's a sulfate ion, -2 ion, it means there are 2 extra electrons are there. It's not a neutral because SO4 with the charge 2 minus. So it means 2 extra electrons are there. And these electrons, oxygen, like example took, so we have to show these electrons. You can use any symbol, like I'm using a square here. So when oxygen took that electron, 2 of the oxygen will have 7 electrons. Say this is 1, and this is another. 1, 2, 3, 4, 5, 6, and then 7. So if oxygen share 1, sulfur share 1 from that side. Same thing, this oxygen share 1, sulfur share 1. So these 2 oxygens are stable and each is -1 charge. So the net charge will be -2. We can write on the top at the last instead of writing individual. Now, sulfur belongs to group 6. So group 6 can share 2 electrons. 2 are already shared. But what happened? How many unshared electron will be there? 4 unshared electron on sulfur. Because group 6 share 2. So unshared will be 4. So these are the 2 which are involved in the sharing. That is completed. And then unshared electron, it can form a dative bond with other 2 oxygen. So 2 of the bonds are dative, like this is a dative bond, dative covalent bond. This one is a dative covalent bond. This is a covalent bond, simple covalent bond. This is also a simple covalent. So this is a structure of SO4 with a charge -2. The shape of sulfate ion. So how we can predict the shape? Whenever you want to predict the shape, you have to check the bond pair and the lone pair. So you can see there are 4 bond pairs are there. On the central atom, you always check the central atom. So central atom is having 4 bond pairs and there is 0 lone pair. 4 bond pair and 0 lone pair. What should be the shape? The shape should be tetrahedral. So it has a tetrahedral structure. Because 4 bond pair in the center and there is no lone pair. The next is many sulfate 6 compounds are soluble in water. However, lead 2 sulfate 6 is sparingly soluble. 0.05 grams is there mixed with 250 cm cube. Calculate the mass of undissolved. Solubility is 1.26 mole per decimeter cube. Molar mass of a lead sulfate is given to us. So we want to calculate what mass does not dissolve. That is what we need. So first, how much like a mass of a lead sulfate that should dissolve in 250 cm cube? Or you can also find the moles of lead sulfate dissolve in 250 cm cube using a solubility, and then the total mass subtract or total moles subtract the moles which are dissolved, you'll get the moles of undissolved, and then multiply by molar mass, you will get the mass of undissolved. So this is a solubility given, like this many moles will dissolve. 0.05 grams of a lead sulfate mixed with 250 cm cube. So both ways are acceptable. So first we'll find the moles of lead sulfate. Moles equal mass in grams 0.05 divided by molar mass, which is 303.3. These are the moles which were added. So 0.05 divided by this will give us 1.64 into 10 to the power minus 4. These are the moles which are dissolved. Like these are the total moles. But how many moles will dissolve? We have the solubility. Like how this many moles dissolve in per dm cube. So the moles of lead sulfate dissolve in 250. The solubility is given and the volume is given. So 1.26 into 10 to the power minus 4 multiplied by volume, which is 0. Because 250 cm cube or 0.25 decimeter cube, this will give us how many moles will dissolve in 250. That is 3.15 mole into 10 to the power minus 5. That will do. So these are the total moles. 3.15 is what will dissolve, and this was the total mole. How many moles will be undissolved? The total moles, which were 1.64 into 10 to the power minus 4 minus 3.15 into 10 to the power minus 5. This will give us 1.33 into 10 to the power minus 4. These are the moles that will not dissolve. And then multiply by the molar mass to get the mass does not dissolve. So 3.03. So it will be 0.04 grams of lead sulfate that will not dissolve in 250 cm cube. Sodium disulfate decomposes on heating to form only two products, sodium sulfate 6 and oxide of a sulfur, oxidation plus 6, write an equation. So sodium disulfate 6, the formula is given in the beginning. This is a disulfate 6 ion. So, and it is sodium is there, so it will become, because disulfate 6 valency was given plus 2, like S2O7 is there with the, sorry, minus 2 was given and sodium is plus 1. So the formula for disulfate 6 ion that is Na2S2O7. We just cross multiply Na2S2 and O7, and they decomposes to sodium sulfate 6. So sulfate is -4, this is +1, so this will form sodium sulfate 6, Na2SO4, plus sulfur in oxidation +6. So if this is +6, the oxide of a sulfur, which like we have two oxide of sulfur dioxide, this is -4, so this will be +4, and sulfur trioxide, so this is -6, so sulfur is +6, so it forms sulfur trioxide. So this is the equation for decomposition, and it must be balanced: 2 sodium, 2 sulfur, 7 oxygen. So this equation is balanced. The next one is ammonium dichromate. On heating, form chromium 3 oxide, nitrogen, and water. So chromium 3, so chromium is +3, oxygen -2, so chromium 3 oxide, Cr2O3, plus nitrogen, N2 will be there, plus water, H2O will be there. And at the beginning, ammonium dichromate 6. So ammonium is +1. And the dichromate ion is Cr2O7 with a charge of -2. So ammonium dichromate will be NH4 in a bracket 2, Cr2O7. This is ammonium dichromate. And the equation must be balanced. So nitrogen is 2, hydrogen 8 are there. So we have to make, because equation, whenever you write equation, it must be balanced. So 4, and then oxygen 7. So 4, it makes 7, and chromium 2. So chromium is 2. So this equation is balanced in terms of all. Next is, we have used a standard electrode potential. Answer the following question. Complete the table using information. So data booklet you have to use, and you have to write it here. This page 14 of a data booklet. It will be there in exam. Give the formula of species which under standard condition are strong oxidizing agent. Look, all the electrode potential are given to gain electron. An oxidizing agent itself, it is reduced, and reduction is by gain of electron. So which one will gain electron easily? That is the strongest oxidizing agent. So it should have a higher value, higher positive value. So which is having the highest positive value? So this is having the highest positive value. So which is the strongest oxidizing agent? FeO4 with a charge -2 is the strongest oxidizer. Because oxidizing agent itself, it will be reduced, and reduction is a gain of electron. All the electrode potentials are given to gain electron. If it is a negative, means opposite will happen. Like if this is a negative value means opposite reaction is feasible. Like this has a tendency to lose electrons. So this is a good reducing agent. SO3. Write equation for disproportionation of a magnet ion. Include a state symbol. Like manganate ion will be oxidized and reduced. Like you have to use any, and state symbols are, so MnO4, if we check this, so each oxygen is minus, so -8, so this will be +6. And here -4, so this will be +4, so this is for reduction. And this is +6 because -8, so sorry, this is +7. This is MnO4, and this one is MnO4, so -8 plus 7 is there. It changes to +2. So what we can do, like the same element oxidize and reduce, we want to write a equation for that. So we can write like m plus 6 can be changed to plus 7, or plus 6 can be changed to plus 2. So here in this equation, we have this is plus 7. So if we can take this one, each is minus 2, each oxygen minus 2. So this is plus 6. And this is also plus 6. So we want to write a balanced equation between these two. Because here what happened, it turned into plus 4. It is a reduction. And here plus 6 will turn into plus 7. So this is oxidation. We want to write a combined equation for this as the same element oxidized and reduced. So how to add these two equations, like the one which is having a higher, because the concept is redox, reduction minus oxidation. For the one which is having a higher, same thing will happen. Like, and the one which is having a lower, opposite will happen. So this will be the reactants. If I erase this part and we write the two equations and add them. So MnO4 with the charge minus 2, in which the Mn is plus 6, has turned into MnO4 minus 1, means plus 7, and then it become MnO2, that is plus 4. Now to write a balance equation, what we can do, to balance oxygen, we add water molecules of 4. Mn should also be balanced, because overall we want to balance all of them. And this equation, it is an alkaline medium. As you can see, OH is there. So this has already OH is also there. The one which is having a positive, the same reactant product, but the one which is smaller value, the reactant will be the product and the product will be reactant. So here we have MnO4, and here also MnO4, and two water molecules are there. So if we balance these two equations, and here we will have a water molecule, 2H2O. So 3, we have to balance the whole equation. So how we work out the reactant product, as I mentioned, the one which is positive value, as you can see here in the beginning, or the one which is having a higher electrode potential, the same thing happen. As we have, because we want a disproportion for MnO4, means manganate 6. So this is turning into, this is a higher value. So this one is reduction will happen and oxidation. So this will be reactant, this will be product, but for the second equation, this will be reactant, the other will be product. And we just add, making the number of electrons same for the two equations, and we will add them. Like multiplying this equation by 2. So number of electrons will be same, and we'll add them, we get the final result. Is it clear? Part C3. How to combine the equation from redox?